So in the previous classes we have dealt with simple microscope. So today we are going to move to compound microscope. Now for the compound microscope we have two lenses instead of just one lens that you have for the simple microscope. So we have a lens, we have another lens. Now this lens is the one that is closer to the object because this is where the object is. So we call this lens the objective. Why this is closer to the eye, you look through this particular lens, so we call it the eyepiece. Now there's going to be a particular distance between the two lenses, that is the length of the microscope. Now apart from this, you should also know that from the diagram you can see that the objective is small and the eyepiece is big. So that's how microscopes, compound microscope, always are. You are going to have a small lens as the objective. That means the objective will have a small focal length, and we have a big lens as the eyepiece. So the eyepiece is going to have a big focal length. Now when this guy forms an image, we are going to place our object, because we actually need this to form a real image, so that when the real image is formed somewhere around here, then this forms a virtual image of this somewhere around here. So the virtual image is going to be behind the object. So this is the setup for a compound microscope. So because this is forming a real image, the real image will be on the opposite sides of the lens. That's why it's here. Because this is forming a virtual image, it will be on the same side as the object. That's why the image is here. So, and as you can see, the image is very much bigger. Now if you look at this is the distance between the two lenses. Now if you look at this distance, we can cut it and say, let's do for this object first. This is our object, right? So distance of object is u, so we represent it as uo. So that's the distance of the object from the objective, right? So now this is the distance of the image from the objective, that's vo. Then this is the distance of the image from the eyepiece, but this image is now an object for the eyepiece. It's now serving as a new object for it. So this is going to be what? U for the eyepiece. Then this distance is now going to be what? V for the eyepiece. So those are the definitions that we have. Then we should know that our V naught plus UE is going to be equal to the length of the microscope. So with this, we will be able to determine some of the functions of the compound microscope. Now the first thing we should note is that we need this guy to form a real image, right? So that means that automatically this object must be somewhere outside the focus, its focus, because if it is inside its focus, it's going to do what? It's going to form a virtual image. So it's going to be somewhere outside its focus, so that it's going to form a real image somewhere around here. Now we need this guy also to form a virtual image, not a real image, right? So that means that we need this object to have entered its own focus. We need the object to have entered its own focus, meaning that our UE must be less than the focal length of our eyepiece. Is it going to be less than it? Yes. So the object will fall inside its focal length. So that's why I'm writing something like this. So this is the basics of how a compound microscope is going to work. Now you can be asked how to calculate the magnification of a compound microscope. So how are we going to do that? What we are going to do is that we look at the angle, we look at the okay, let's do this. So the magnification of the compound microscope is just the magnification of the objective multiplied by the magnification of the eyepiece. Now the magnification of the objective the objective is functioning as a normal lens, right? So its magnification will be v naught over u naught multiplied by the magnification of the eyepiece. Now the eyepiece is functioning as a what? As a simple microscope. So that means that we use magnification of simple microscope for it, which is d 1 over f of eyepiece minus 1 over distance of image, right? So that is v of eyepiece. So this is the formula that we are going to use to get the magnification of our compound microscope. Another way you can write this formula is v naught over u naught. Don't forget that this formula we already proved in the previous video that it is also d over ue. So this is another way we can get the magnification of our compound microscope. So the questions here are always going to be that easy. So let's try this question. It says we should find the magnification of a compound microscope. We have the foci. So one foci is 2 centimeter, one focus is 2 centimeter, the other focus is 0.5 centimeter. Now this is bigger, so this will be for the eyepiece, so this is going to be for the objective. Don't forget that. So even if they did not tell you, you should know that this is it. Then the length of the microscope is 25.6, no, length of the microscope is 14.9 centimeter. So that's the distance between the two lenses. Now we have to find the magnification of the compound microscope when the eye is relaxed. So when the eye is relaxed, how are we going to do the magnification? Now don't forget that magnification is what? That of objective multiplied by that of eyepiece. Or you replace this. Okay, you can leave it like this. So now we need what? They said when the eye is relaxed. Now what's going to happen to when the eye is relaxed? Now we know that when the eye is relaxed, this part is going to become d over fe. D over fe. That's what it's going to become, right? Because when the eye is relaxed, this is the magnification. Please don't forget that. You can check the video on simple microscope. You know that this magnification when the eye is relaxed. So and d is what? 25 centimeter, right? So d is 25 centimeter. Focal length of eyepiece is what? 2 centimeter. So that means that we can get this. Now remaining this. Now don't forget that we said it that the length of our lens is what? Distance of image from objective plus distance of object from eyepiece. U naught plus v naught plus ue. Is that what you wrote? Yes, that's what we wrote here. Now in this case, what's going to happen in this case is that since the eye is relaxed, it means that the object, the final image is at infinity, right? So if the final image is at infinity, that means this guy is forming image at infinity. So what it means is that the object is at its focus. The object is at its focus. So that means that our ue is going to be equal to fe. So then we are going to say the length of the our lens is what? Length of our camera is what? Length of our microscope 14.9 equal to, we have v naught plus ue. Now what's ue? That's fe. That is 2. So we are going to get our v naught. We are going to get v naught to be equal to what? 12.9 centimeter. So that means that the object is, the image is 12.9 centimeter from the objective. So if it's 12.9 centimeter from the objective, then we can get its magnification. So instead of doing normal and doing v naught over u naught, another formula you can just use is v over f, v naught over focal length of objective minus 1. So this is another formula that you can use. So this formula, you could have done it normally, just use this, then use 1 over f is equal to 1 over v plus 1 over u to get your u, then do v over u, you still arrive at the same answer. But since I know this formula and I already have v naught, so I don't need to do that again. So then this magnification is going to be what? 12.9 divided by f naught is what? Focal length of objective is 0.5, then minus 1. So if I do this, 12.9 divided by 0.5 minus 1, I have 24.8. Then I can do for the objective, for the eyepiece. Magnification of the eyepiece is what? 25 divided by 2. That's what? 12.5. So I will just multiply the 2, 24.8 multiplied by 12.5. So that's going to give me 310. So the total magnification is 310. So that's magnification when the eye is relaxed. Now what about when the eye is stressed? When the eye is stressed, you know that the distance of the image as VE, the final distance of the image from the eyepiece is what? Is going to be 25 centimeter, right? So, and we can its magnification of the eyepiece will be what? D over f plus 1, right? Focal length of eyepiece plus 1. We use this for the eyepiece. We have done this before. So what we now need to know is that, for the objective, we need to find its own object distance, right? So that means that we use the length of the microscope. The length of the microscope is the distance of the image from the objective. That's what? VO plus the distance of that image from the eyepiece. But that image is the object for the eyepiece, UE. So that means that we need to get the value of UE, right? So to get the value of UE, we use 1 over FE equal to 1 over UE plus 1 over VE. Now this is going to be 1 over, what's the focal length of the eyepiece? The focal length of the eyepiece is 2 centimeter. So this 1 over 2 equal to 1 over, now this is for the object, right, which we are looking for, plus 1 over, now this is the distance of the image, which is 25 centimeter, but it's a virtual image, so we use negative. So we get 1 over UE equal to 1 over 2 plus 1 over 25. So we get a value for UE. You can use our calculator to do this. 1 over 2 plus 1 over 25. Then we do the inverse. So answer is 50 over 27 centimeter. So that's what UE. Now knowing UE, we just come here, we say 14.9 equal to what? 14.9 is equal to V naught plus what? Plus 50 over 27. So we get V naught to be 14.9 minus 50 over 27. So we have 14.9 minus that. So we have 13.05. Now we can calculate the magnification. So the magnification for the objective, that's what? V over F, distance from the objective, focal length of objective, minus 1. So this is going to be what? This is going to be 13.05 divided by focal length of objective is what? 0.5 minus 1. So if we do this, divided by 0.5 minus 1, so we get 25.09. Now when it is 25.09, what do? You just need to multiply the two values, right? So the previous, okay, we have not done this. So this is going to be, for the eyepiece, is going to be 25 divided by, is that 2? Focal length of eyepiece is 2. 25 divided by 2, then plus 1. So 25 over 2 is 12.5, so this is going to be 13.5. So we have 338.8. So the total magnification is 338.8. So that's going to be our final answer. Though there are some textbooks that they won't do this. They use a different formula, but this is the way it's supposed to be done. That one that they used to do, I think, is when they are looking for the minimum, the maximum magnification. Like that's it. It should be the maximum magnification. But this question is not asking us to find the maximum magnification. What are we looking for? The magnification under the conditions that we are given, not the maximum. So let's continue. We've done A, we've done B. So C is when the object is at 0.52 from the objective. When the object is at 0.52 from the objective. So distance of the object is U from the objective is 0.52 centimeter. So what are we going to do? So what you are going to do is that we find V for the objective. So how do we get that? We do 1 over F naught equal to 1 over U naught plus 1 over V naught. So this is what 1 over focal length of objective is 0.5 equal to 1 over 0.52 plus 1 over V naught, right? So what are we going to have for the value of V naught? So that's 2 minus 1 over 0.52. So we have V naught to be 13 centimeter. So if V naught is 13 centimeter, we can get, this is the distance from the objective, right? So we can get the distance from the eyepiece by using the length. The length is the distance of the image from the objective plus the distance of the object from the eyepiece. So this is what 14.9 equal to what? So our V naught is what 13 plus UE. So UE is going to be equal to what? 14.9 minus 13. So that is 1.9. Now since we know the distance of the object from the eyepiece, we can easily get its magnification. Don't forget that there are two formulas. You can also use D over distance of object, right? So distance of object. So that's going to be what? 25 divided by the distance of the object is what? 1.9. So 25 divided by 1.9. So we have 13.16. Then we can find the overall magnification. So we already know this is what 13 divided by 0.52 multiplied by 13.16. So our final answer is 328.9. So that's the overall magnification. So don't forget, you have to be subtracting from the length of the lens. So then you have to be smart also. Let's assume that this distance is not 0.52. Let's assume that this distance is something less than 0.5. Let's say 0.4. So that means that here you have 0.4. So you have 1 over 0.5 minus 1 over 0.4. So the answer will be minus 2. So that means that it's forming a virtual image, and the image did not even get to the object, the eyepiece. That means that the image is here instead of being in front of the eyepiece. So that image is very far from the eyepiece, and it did not even enter the focal length of the eyepiece. So it's not possible for the eyepiece to form what? A virtual image of that image. So that question will not be possible. Or they give you a distance, they give you a length of the camera that is so large that the object did not enter its focus. Because look at what you got for the distance of the object. What did you get for the distance of the object from the eyepiece? Where is it? We got 1.9. 1.9 is within its focus, which is 2 centimeter. So I don't mean that this distance is more than 2. That means that it will not be able to form a virtual image of it. So that means it's not going to function as a what? As a microscope that it's supposed to function as. So that means that the question might be wrong, or you can just consider it as no longer being a microscope, no longer being a compound microscope. So we have done this, and this is what, when the final image is at 25.6 centimeter from the eye. Does this make sense? Yes, because the image cannot come closer than 25. Now it's at 25.6, so that means it makes a lot of sense. So that means that the final image from the eyepiece is what? 25.6 centimeter. Now don't forget that this image is what? Is a virtual image, so this should be negative. So we can easily, since we know the distance of the image, we can get its own magnification, right? Now its own magnification is what? D1 over focal length of eyepiece minus 1 over distance of image, right? So, and we already have the distance of the image, so you can easily get its own magnification, but we need the magnification of the other one. So how do we do that? So we convert this, we move from this, we use this to get UE, distance of the object from the eyepiece, then we subtract it from the length of the lens, so that we can get the distance of the image from the objective. So then we will be done. So UE is going to be what? So we use 1 over FE equals 1 over UE plus 1 over VE. So this is going to be what? 1 over focal length of eyepiece is 2 equal to 1 over UE minus 1 over 25.6. So you just have 1 over 2 plus 1 over 25.6. So please learn how to use your calculator very well. So we get UE to be equal to the inverse of this. So that is 1.86 centimeter. So we subtract this from the length of the microscope. So we say our V of object is length of microscope minus UE. Don't forget that this is what you have been looking for, this is what you have been using. So what will happen? So V is going to be, the length is what? 14.9 minus UE. Now UE is what? 1.86. So we are going to get 14.9 minus 1.86. So we have 13.04. 13.04. So for the object to be at 13.04, if you compare this for the objective has a focal length of 0.5, right? Double that, you have what? 2. So that means that the object distance is greater than 2f. So that means that the image must have been between f and 2f prime. So don't forget all those ray diagrams that we have been doing. So this makes a lot of sense. It makes sense. So what are we going to do? So magnification of the objective, since we know V, that will be 13.04 over its focal length, which is 0.5 minus 1, times the magnification of this is going to be what? D, which is what? 25, then 1 over focal length of eyepiece, which is what? 2, minus 1 over distance of the image is what? 25.6, right? So that will be minus 1 over 25.6. But don't forget that this image is a virtual image, so this should be plus, because we are having a virtual image. So don't forget that this should be negative, so that will turn this to a plus sign instead of a minus. So if we do this, 13.04 divided by 0.5 minus 1. So we multiply that by 25, multiply that by 1 over 2 plus 1 over 25.6. So our final answer is 337.9. So that will be the total magnification. 337.99. So that will be the total magnification of our microscope, compound microscope. So that's everything on compound microscopes.